Hello class, our topic for today is motion. When discussing motion, there are three related concepts that you need to know. First, we have position. This determines where the particle is located on the x-axis at a given time. Second, we have velocity. This determines how fast the position is changing at a time t, as well as the direction of the movement. Thirdly, we have acceleration. This determines how fast the velocity is changing at time t. The sign indicates if the velocity is increasing or decreasing, or in this case, positive or negative. First, we have the numerical example. We are given a chart telling us how s is moving along time t. It wants us to estimate the velocity using the difference quotient. First, at t equals 0.5 seconds, we have to find 1 s prime 5 seconds equals s of 1 minus s of 0 over 1 minus 0, and we have 30.2 minus 40 over 1 minus 0, which equals negative 9.8. And we can't forget units, feet per second. And for B, at t equals 2.7 seconds, we have s prime 2.7 equals s at 3 minus s at 2 over 3 minus 2 equals 38.2 minus 48.2 over 3 minus 2 equals 10, negative 10 feet per second. Now we have the graphical example. So it gives us a graph, and A is asking us when is the particle moving to the left. So judging by the graph, right here, the slope is 0. From 2 to 4, slope is less than 0. And from 4 to 6, slope is greater than 0. And from 6 to 7, the slope is back at 0. So when is the particle moving to the left? Is moving to the left when the slope is negative, and from 2 to 4, the slope is negative. Two to 4 seconds. And B is asking us when is the particle moving to the right? Well, it's moving to the right when slope is positive. So from the graph, it goes back to being positive from 4 to 6. So that is our answer, 4 to 6 seconds. When is the particle standing still? Well, the particle is standing still when the slope is 0. No velocity. So from 0 to 2 and from 6 to 7. Velocity is stagnant. 0 to 2 seconds and 6 to 7. Finally, we have the analytic example. So a particle moves along the x-axis so that at time t, its position is given by the function right here. At t equals 0, is the particle moving to the right or to the left? Explain. So we want to take the derivative at 0, which equals 3 squared minus 12 0 plus 9. That equals 0 minus 0 plus 9 equals 9. And we could say that it's moving to the right because 9 is greater than 0 and it's positive. Alright, now we have B. At t equals 1, is the velocity of the particle increasing or decreasing? So we want to take the double derivative at 1, which would equals 6, 1 minus 12. That will give us negative 6, and is decreasing because negative 6 is less than 0, and that's negative. Here's an actual AP free response question. As you can see, we have a data table at the top, and A is asking us to find the average acceleration of rocket A over the time interval from 0 to 80 seconds. Indicate units of measure. So we're going to be using this and this. So we have V of 80 minus V 0 over 80 minus 0. This will give us 49 minus 5 over 80, which will give us 11 over 20. Don't forget the units. Feet per second squared. Make it more clearly here. Answer is 11 over 20 feet per second squared. Here we have another free response question. This time they give us a graph and they want us to find f prime of 22. F prime of 22 will be located right around here. So we have f prime of 22, and we're using these 2 points. So that will be 15 minus 3 over 20 minus 24, which will equals negative 3. Don't forget the units. Calories per minute squared. And that is your final answer. Now here are some practice problems for you to try. Now here are the answers to the problems. Alright guys, thank you for watching. If you have any questions, please ask the teacher. My name is Big Ant, and I'm out.